Today we're going to talk about something that sounds almost too simple to be true. Cleaning water using nothing but tiny, tiny bubbles. Seriously, it's this really cool story about how a little bit of smart physics and some clever chemistry can team up to make our water a whole lot cleaner.
So, let's start with the big problem. Imagine water that's full of gunk, but it's stuff that's so small you can't even see it. We're talking microscopic bits of clay, dissolved organic material, you name it. They make the water cloudy and unsafe, but they're way too tiny to just filter out. So how do you even begin to grab something that small?
Well, the answer starts with this brilliantly simple piece of engineering called a Venturi tube. The whole idea is just to use the shape of a pipe to create this really powerful effect. It's step one on our journey to cleaner water.
Okay, so this is the core principle we're working with. It might sound a little technical, but the idea is actually super elegant. All it means is that the faster a liquid moves, the lower its pressure gets. So, just by changing the shape of a pipe, you can completely change how the water inside it behaves. No fancy motors or anything, just really smart, simple design.
Think about this. You've probably done it a million times. You put your thumb over the end of a garden hose, and the water speeds up, right? A Venturi tube basically does that, but in the middle of a pipe. Water flows in, gets squeezed through this narrow section, and speeds way up. As it rushes through that tight spot, the pressure drops so much that it creates a vacuum. A vacuum that literally sucks air right into the stream of water. And the best part? No moving parts. It just works.
So the Venturi tube pulls air into the water. Big deal, right? We've all seen bubbles. But, and this is the really cool part, the magic isn't just making bubbles, it's the kind of bubbles it makes. These aren't the bubbles from your can of soda. Nope. These are microbubbles, and they basically have superpowers.
Just look at the difference here. Normal bubbles are pretty big, they float up, and they pop. They're gone in a second. Microbubbles, though, are 100 times smaller. They're so tiny they just hang out in the water instead of escaping. Plus, they have a natural negative charge, and when you get millions of them together, they have an absolutely massive surface area. Those three things right there, that's what makes them a game changer for cleaning water.
When you flood the water with millions and millions of these little guys, the water actually transforms. It turns this milky white color, but more importantly, it gets super oxygenated. I mean, it gets packed with way more dissolved oxygen than it could ever hold naturally. And the data completely backs this up. Research shows this whole process can get the dissolved oxygen level up to 8.1 milligrams per liter, like almost instantly. That high oxygen level is fantastic for the overall water quality, but it also gets the water perfectly prepped for the next step of the cleanup. Okay, so now we've got this milky, super oxygenated water that's full of tiny, negatively charged bubbles. How does that actually get the junk out? Well, this is where our microbubbles team up with some regular old water treatment chemicals to do something pretty amazing. Let's meet the players in this little drama. First, you've got your bad guys, the impurities, the little bits of clay and organic stuff. They have a negative charge. Then you've got our heroes, the microbubbles, which remember, are also negative. To bring them all together, we introduce a coagulant, which is basically a tiny little magnet with a positive charge. And for the grand finale, we bring in a polymer called PAM, which acts like a giant net.
So here's how it all goes down. First, those positive magnets go in and cancel out all the negative charges on the impurities and the bubbles. This stops them from repelling each other, and they can start clumping together. Then, we add the polymer net. It sweeps through and gathers up all those little clumps into big, heavy chunks we call flocks. And once they're big and heavy like that, getting them out of the water is easy.
So the big question is, does this whole team-up actually work any better than the standard way of doing things? Let's take a look at the results, because this is where you can really see how much of a difference those microbubbles make.
First up, let's talk about turbidity. That's just a fancy word for how cloudy the water is. So, using this standard method, you get rid of about 77% of the cloudiness. Not bad. But add in the microbubbles from the Venturi, boom, that number jumps to over 82%. That's a pretty big improvement in how clear the water is.
And then there's the dissolved gunk, or what scientists call dissolved organic carbon. This is the invisible stuff that can make water taste and smell bad. And what do you know? The Venturi method wins again. It boosts removal from around 85% to over 87%. This shows the microbubbles don't just grab the physical particles, they help get rid of the dissolved stuff too.
So here's the real takeaway. The Venturi process isn't trying to replace the chemistry we already use. It's just supercharging it. The microbubbles are like a catalyst. They create the perfect conditions for the chemicals to work better, making a pretty good system way more efficient and effective.
When you step back, it's pretty incredible. A simple idea. Just squeezing water through a pipe to make special bubbles can have such a big impact on cleaning water. And it really gets you thinking, if this simple, low-energy trick works so well here, what else could we use the power of microbubbles for?